Okay, so we have the paper, and there's a lot in the paper. One of the reviews said that he thought it should be 2 papers, but there's a particular problem we're trying to address, and if we split it out, it wouldn't be clear. And so the first thing is I'm going to talk about a schema term, and this relates, Enrico, to the second, in some case, a little bit to the second question I asked you. And I'm going to try and suggest that this particular term, this particular way of working, is from an evolutionary perspective, is just a small detour. If we stand back and we look in terms of centuries rather than decades or whatever, it'll be a different way of doing things. The structure I'm going to do is try and explain what the schema term is. I hope it's going to be non-controversial. I suspect it'll turn out not to be. One of the things that we found is that when we're trying to explain what the problem was and how we fixed it, is we needed to introduce extra tools. It wasn't the tools out for examining weren't out there. The first one is something relatively new. Okay, sorry?
It sounds like a call coming in.
Yes, okay. All right. And then try and show that if you have this modularity framework, there's a certain structure emerges out of the way in which you look at things, which has an implication about how you're going to design things. And then I try and provide an example, particularly in this case, package application migration, that shows that ignoring what we call the base, the information base, which you can think is data, doesn't sound like a good idea. And then talk about some work that we do. We have a methodology called bCLEARer, where we actually combine the schema and the base and just try to talk about, so say that we actually do this work, it seems to work. So it's not like, we're not talking about a theoretical situation, we're talking about something that's actually done and then finished. I suspect most of you here will recognize the picture here. You probably know it far better than I do. This the 87 technical report is quite useful. It said it suggested that there's a universe of discourse, something you're interested in, and you can divide up into 2 bits, into a schema and a base. Information base, I think some people use now, but very few. But I think historically it's the correct thing. So as I go through, I'm going to use it. Also, there's just a point. I'm talking about computer science conceptual modeling here very much. I realise there's a much. In fact, you guys have done lots of really interesting work about how wide if you like, the scope of conceptual modeling is. But I'm focusing just on this particular slide here, and I'm going to suggest yes. I think they say in the paper they talk about UODD, Universal Discourse Description. I'm going to talk about schema and base, and I think that if you look in the literature, and it's quite well, I can talk about it in a second. Try to find the roots of the term conceptual modeling. I found. Admittedly, my exegesis wasn't massive, but I found it quite difficult to actually find. Okay, I'm not the only one. So let's look at things. Okay, so if we go back here, I'm going to suggest this is like a static division. You're looking at a division, you're looking down, you're saying I'm dividing into this and this. But what happens, and you can actually see it in the technical report, and I'll come back to that in a second, is that actually you have this dynamism that's going on during development. And what happens is at the early stage with logical and physical data modeling, the tendency is to work solely at the schema level and not to work at the information base level. And this picture here is a picture we've listed off the web that appears in all sorts of different places, maybe more from the practical end than the academic end. They're saying that there are these 3 stages. And I think you can find something similar in most database textbooks. When you look at the data textbooks, it came up again and again. And I think that what we're saying is that the schema turn is a bias towards, at the early stages, when you're doing a logical data modeling, is you just look at the schema and not at the base. So you eventually have to have the base, because otherwise the system won't work. So it's this question as over time, you prioritize looking at the schema at this stage. And what happens is you get the standard shift left problems, is that this is the stage where you decide what the conceptual model looks like. By the time you come to putting the data in, you've already made all these decisions and the cost of change is high. This will be a bit clearer, but we're trying here to show sort of the picture that goes through. As you start with a schema, you ignore the base completely. You physicalize the schema, so you put your physical transformations over the schema, and then only at the end end and the base. And so this is if you like, trying to say that what's happening here is that the way you modularize things, so the way you modularize schema and base, the way you modularize physical and schema and base, these modularity choices are defined, or it's the perspective on the structure that you want to look at. And when you look at it this way, it's quite plain that you've made this schema turn. You've done this focus on schema. Okay, so this is just trying to summarize where we are. So we want to look at how the turn emerged. We want to try and also say that the turn isn't fundamental. In other words, you don't have to make this turn. There may be cases you want to, but there are also cases where you don't want to. So it's not, if you like, doesn't have to be universal. And what this does is I think it opens up the space of possible conceptual modeling practices. There are things that we do at the moment that we don't think of as conceptual modeling that we should think of from the perspective of conceptual modeling. So these are the two analysis frameworks, and I'll zoom through. The first is the language to enable us to talk about modularity, and we do it in terms of architectural styles. And we suggest that actually the schema turn is an instance of a choice of architectural styles, which is separating the base from the schema. And then we do this, we do an information evolutionary context, and this is in a sense trying to understand what drove the schema turn to turn up, and we're going to argue that because the context changes, there's no longer the pressures for making a turn. So, okay, this isn't animated quite the way I expected. So the notion of architectural styles is quite strong in software engineering. It's Shane and Gar. I can't remember who it is now. Shaw and Garland. Yeah, okay. And basically, you take the notion of architectural styles, and then you mix it in with a hylomorphic framework. You've now got a language to talk about modularity. Hylomorphism, starting with Aristotle, and the idea is you have matter and form, and you mix them together, and you get substance. And we're going to do a similar thing with modularity. So first of all, in this case, the forms are very, very simple. You don't need the complex structure that you do for substance. And we say that things can be integrated, so they're so tightly bound together that you can't separate them. They can be aggregated, so they're in a mixture where you can separate them. They keep their what's going on. They can be separated, or in the case of this is the thing that we really want to say, they can be isolated. So you can take one part and ignore the other. And what we're saying is that what you do is that this is a form a la Aristotle, and this is the equivalent of matter, which is a distinction. In this case, is schema-based. And you can see that you get, depending on how the modularity form that you choose will dictate different structures at this level. And we're suggesting that probably this is a good way of doing certain things, whereas at the moment, this certainly for the first logical modeling, this is the way most people do their form. Oh yes, and we're doing the same sort of thing on here. We're saying if we reinterpret this logical physical model that we had from earlier, you can see that this logical data model is a schema, the physical data model is physical for schema, and then when you put the data in, you're getting this join model which is aggregated, and it's aggregated because it's a clear separation. Particularly, I mean, Enrico, in your thing, you've got a separation between the schema and the rows. You know what the difference is. Well, in a graph database, you could argue the structure becomes more mixed. I think if you want to look more about in the paper, one of the things that we found out is when we started applying our way of one of the things, the other things that we looked at is trying to put, if you like, the whole history of let's put it differently. If you can see computing as the latest stage in information revolution. That's quite common. So they say there's language, then there's writing, and then there's printing. But actually, there's if you go back, there's actually Maynard Smith and Smartbury have got this structure that says actually the whole of evolution can be interpreted from an information perspective on the different stages. And there's stuff in the paper if you're interested in that, but we haven't got time for it. So, but if we go back to this thing here, is that, and it's something in Nico that I'm not sure, I think we read a different code, is that if you look at this, it seems to be two things going on. There's a Mealy Chen thread where they're worried about what happens in the real world, and Cod doesn't mention the real world anyway. I've been through his papers, maybe I missed something. He doesn't mention the real world, and he's not worried about entities at all. And it actually goes through on some of these things here. You can see the same thing going on. And the first time that we could find, again, we've not done detailed exegesis on this, is the 87 report, where they sort of, the two views, they what's the word, align the two views about what's going on here. Also, interestingly, again, I think, as I said earlier to Steve, is that trying to find the term conceptual model in any of these papers is, well, we couldn't find it. The 87 paper is interesting as well because it begins to hint about the schema term and the dynamic change. So at this stage, it's got the separation, the static state. So you've got quite clear the distinction. This is showing as an aggregation like this, but in fact, it's unclear what's going on because there is, let me just see, there's a quote down here. It's beginning to hint that if you're trying to do an implementation, maybe you've got to go about it a different way. Maybe you've got to start with a schema. And what we is more in the paper, what we want to claim is that at the stage in which this work was being done, so maybe the late 70s, 80s, maybe even up to the early 90s, there wasn't a tool to support engaging with both the schema and the base. So you need to reduce the scope of what you're going to do to something, and it made sense to, which I think is the second point, the tools made sense to focus just on the schema and ignore the base. And also, there wasn't much base. If the systems you're working on are greenfield, you don't have the data to work with. And I mean, I'm just going back, I'm not sure, but there's a few of us who are old enough, but I can remember in the late 80s trying to work with building models and having to use graphic tools. There was no repositories. The tools were really, primitive. What I'd like to do here is now try and make the case with two different kinds of examples. The first example is to try and say, let's look at a particular example of a domain or a use case and show that it makes sense to focus on the base. And the second one is to just report on work we've done in a particular methodology where we do include the two and what happens. So let's go on here. So if you think if you're doing a package application migration and it's particularly simple and you're a novice, probably the first thing you do is you take the data from the source system and map it straight to the target system, and you just do it on a single mapping. If you are more sophisticated or it's a bigger task, you might put something in the middle. But at each stage here, what happens is that if you look at it, is you're actually migrating the base. You're not migrating the schema. And if these are the reason we chose packages is the source app structure is given, the target app structure is given. You don't have any control over it. So the only thing that you can be doing in terms of moving is you're moving the base. So the focus is on base. So in this situation, there is not a, you can maybe argue for building the schema, there's not there's not a sensible approach that starts with just a schema and ignores the base. There's a nice, interesting analogy here with Weissman. If you go back to biology, Weissman was pointing out that it's the germ cells that survive. So if you imagine, this is in sexual reproduction, is that it's if you trace back the lineage as you go back, the lineage goes back on the germ cells. So in other words, if you think if you have children, is that your children are going to come from your germ cells, not your body cells. So if you think of the cells in your hands, your brain, they had no impact on your children. It was only the germ cells. And the interesting thing that he notes is that he has his notion, there are all sorts of subtle, complicated problems with the Weissmanian thing, but there's a nice analogy at a simple level, is that the germline is immortal. So if you then think if I've got a series of these package application migrations, which is common in the enterprise now, say you've got 7 or 8, you have a germline, which is the base data, and it's not the schema. So all the focus on trying to organize the schema has usefulness, but underlying it, what's actually moving along, what's actually persisting through time is the base data. I think this was, yeah, okay. I think that's what I said. How am I doing for time? Am I okay?
15 minutes.
Yeah. Oh, okay. So that's not what I expected. Okay, so I might be little bit slower now. Okay, so the context here is that tools have been evolving, and there's been sort of a movement. If you see what you've got, this early case, and people who can remember Accelerator, I can. Doing a bit on the information engineering workbench, using various things, the emergence of UML, and now you've got sort of more model-driven engineering. You've got different ways of doing things now. There's some much less reliance on GUI editing in the more modern things you'll notice. And I think you've also got something happening at the moment. You've got more and more data pipeline type ETL going on. If you look in the landscape of what people are doing, and into that landscape here is work that we've been doing. So what we found actually for quite a long time is that we were running our conceptual modeling as a pipeline. So we're doing data modeling as a pipeline. It started out in the late 80s and early 90s, and it's been going for a while. In the early days, it was more of a manual effort because the tools weren't there. And then over time, it's become more and more automated. And one of the things that, if you like, prompted this is that because we tend to work the data pipeline with data, we start with the schema and base. So our starting point is always the schema and base. There's no motivation for us to start with a blank sheet of paper, to start with a schema when we're doing these things. It's intriguing that from a tool perspective, it's much more like a data pipeline, if you like, than a sort of UML GUI type, though we do use UML and GUIs to do some of the design in terms of the way it works. Okay, so the lessons that we've gone from bCLEARer, there's some familiar lessons, is that automation is good, so you try and find out ways of increasing automation. And when you do, particularly on the pipeline, you need to increase, as you get the levels of automation get really high, as get fully automated, the need for observability and inspectability increases enormously. And the benefits of doing it. There's a less familiar lesson, these two, which I quite like to talk about, is that it's always puzzled me what a conceptual model is, how to describe it. And I think one of the things that comes out is when you look at the way, if you look at this more pipeline way of doing things, and I'll explain this in a second, it has a show rather than a tell view of modeling. And there's also, because of the cost profile and the way it works, it allows a form of epistemic modeling that is less easy, I think, to do. It'd be interesting to see how you react to it, because I think you could make claims that the traditional way, GUI-based way of schema GUI-based way of doing conceptual modeling, you could argue there's some kind of epistemic action. And I'd be interested to, my gut feel is that it's less easy to do in that environment. It's easier to do in the pipeline environment, but I'm happy to listen to arguments the other way. But it'd be interesting to do it. Okay, so this is, I'm trying to do the show and tell. So I think what happens is that if you've got if your logical model if your conceptual model is only of the schema, when you build your logical model, it's easy to try and say, okay, and it's in the standard textbook. Now I'm doing my model. My model is describing the data. It's not describing the real world. It's easy to make that shift. And then the physical model is describing the physical system will be implemented, probably on these model-driven system engineering, not so easy. And then it's only at the physical system that the actual stuff goes back to describing the real world. But what we find is that when we're running pulling our data in the schema base, if you've got all the base data there, the logical model looks just like a picture, just like a model of the real world. This tie is much closer. And there's interesting work done in logic and philosophy of mathematics. Am I doing this? Where is it? Yeah, show and tell. So there's Daniel Macbeth has got an interesting paper called Seeing How It Goes. She's building up, she refers to Whitehead and makes a similar point. And in mathematics, there's some ways of doing mathematics where you show what's going on, and there are other ways in which you tell what's going on. And she has a very practical example, again, which Whitehead had. If you look at Arabic and Roman numerals, When you try to do arithmetic with Arabic numerals, you're showing what goes on. You can see what's going on. You move it around. You try and do the same thing with Roman numerals. You can't do it because it's telling you what's going on. And this distinction about whether you have this jump before, about what's going on. And it seems that I think one of the arguments, one of the strengths of the conceptual model is you're trying to show the world rather than tell about the world. You can see this desire to try and have the conceptual model being a description of the system of the world, even in Mealy, when you go back here. I think he talks about the different levels, this 3-layer architecture. And in fact, I mean, I have a paper with Mark Lysa where I make the same, okay. 5 minutes before questions or 5 minutes before the end?
Sorry, we've got 10 minutes left in your portion.
Okay,
so
I've got,
you want to reserve for
yeah, okay. It should be quick if I remember how this goes. Okay, so the other thing that's quite interesting, and this is a picture from Andy Clark's book, The Experience Machine, is this notion of epistemic actions. And what he's saying, he's finding, he's trying to make a story about how the mind works. And he's saying that often we think if we want to do something, we've got to set our goal, and we've got to do the steps towards the goal, and we do these pragmatic actions where we aim for the goal. And he's saying in practice, and they did this work, I think, with some guy looked at the way they were playing games or not, is actually that's not the way in which most people work when they're doing things. You have these epistemic actions where you try and gain information. So you do something that's not getting you towards your goal in any obvious sense, but what it is giving you the information to get to your goal. And this is a picture from apparently orangutans are the intelligent primates, not us or chimpanzees, but orangutans. And this is Migo, and what he's doing is he needs to get across the river, so he's getting the stick and he's trying to find how deep it is. When he knows how deep it is, he then decides how he's going to go across. But doing this is not, if you like, getting him across the river. So one of the things that we found we were doing naturally when we're doing our, and in fact, actually, if you talk to anyone who does data pipelines, is you're running, basically, your pipeline changes all the time in the early days because you've no idea how it's going to finish off. So what you do is you do all sorts of experiments to see what's going to work and what's not going to work. So you're doing a series of epistemic actions. So you're not trying to model the world, you're trying to say, how does this fit? So then I can model the world better. Am I right? Okay, so yeah, if you want the reference, this is the original version. Yeah. Okay. So I'll say I want the feedback. I think I do want the feedback. I hope it's uncontentious that there's been a schema turn. It'd be seriously intriguing for me if you said there hadn't been a schema turn. You explain why. I would like to. I suspect I haven't persuaded all of you. Hopefully, I've persuaded some of you that this turn where you have this isolation modularity structure isn't the only possible way forward. So I'm not trying to make an argument you should never do it. I suspect it might be the case in 50 years' time that you tend not to do it. I can well imagine that's the case. I don't know. It could be the case, but that's not what I'm trying to argue. I'm merely arguing for, if you like, there should be cases where there may well be cases where you want to isolate. If you want to do it, I'm happy about it. But you should argue there are lots of cases where it's better not to isolate. And we've got these working results, so I can talk more about it. And I think the thing that I'm intrigued by is that when you do that, you have a different feel or notion of what a model is. So you've got this show and tell difference, and you've got this empirical versus rational modeling. So it's things that emerge from the new practices, the ways of working with the new practices, imply that the conceptual modeling space is bigger than people who were stuck with computer conceptual modeling for decades like myself. So there is a new space to go to. And I'm impressed. Oh no, I have one more. So I think this is the idea is just trying to summarize what's going on. The idea is you're not going to sit by a terminal with a screen doing stuff. You're going to be running these things and examining what's going on. And if you look at it from a modularity map point of view, this is trying to justify the work we did on modularity mapping. And here you've got this isolated schema here, and you've got an aggregator. There's a human and machine. But over here, there's much. In fact, it's been the wrong way around. We need to look at the slide. There's no human, it's all machine, and the schema and base is aggregated. So they've got a different modularity profile, the two ways of working.